Think math.
There are two ways to hand someone a sequence. One is to give the n-th term outright, like 3n plus 1. The other is to give only the rule for stepping to the next place. The first number is 4, and each next number is the one before plus 3. The second way never tells you the 100th number directly. So is the 100th number even decided? It is. Think of dominoes. Once the first number is set at 4, the rule fixes the next one at 7. 7 then fixes 10, and 10 fixes 13. The moment one place is settled, the next one is settled too. So the chain never breaks, whether you want the 100th or the 1000th. One starting point and one next-door rule decide the whole sequence. That does not mean 99 calculations. The rule says add 3 every time, so this is an arithmetic sequence. Start at 4 and add 3, n minus 1 times. Tidied up, that is 3n plus 1. Put in 100 and you get 301. The next door rule has been turned into a one-line formula. What if the rule multiplies instead? Say the first number is 3 and each next number is double the one before. 3, 6, 12, 24. That is a geometric sequence. Here the n-th number is 3 with 2 multiplied in, n minus 1 times. The shape of the rule tells you the kind of sequence. Adding gives arithmetic, multiplying gives geometric. One thing matters here. A next-door rule with no starting point does not decide a sequence at all. With the same rule, starting at 1 gives 1, 4, 7, 10, while starting at 10 gives 10, 13, 16, 19. The rule sets which way you travel. The starting point sets where you begin. You need both before the path is a single one. To sum up, a rule for stepping to the next place is called a recurrence. One starting point and one recurrence settle the whole sequence, like a line of dominoes. If the rule adds, the sequence is arithmetic. If it multiplies, geometric. And either way, you can turn it into a one-line formula and reach the 100th in a single step. Next time, we take on a trickier rule that multiplies and then adds. A sip of math, every day, here at Think Math.